Good morning or good afternoon, gentlemen, depending when you are watching this. I'm going to be going over the lectures for average atomic mass all the way up through the periodic table that we did this week for you. So if you only need to watch one or the other, then that's it. All right, so first things first, average atomic mass, we kind of talked about this. It's really important with calculating because you wouldn't want me calculating your grade this way. You wouldn't want me to take 5 tests where 2 are worth 10 points and the last 3 are worth 80. And the 10-point ones, you only got a 2 out of 10, so 20%. Where on the remainder, you got a 74 out of 80, a 72 out of 80, and a 75 out of 80. Now, I could take the average of all those scores. However, that would not be fair because 2 of the tests are a lower percentage value because they're only worth 10 points instead of the 80 points that the other 3 tests are. So to do this, we do the average atomic mass. And this is the decimal number of, the decimal number that's the red number on your periodic table. An average atomic mass is a weighted average of all the different isotopes, and it considers the isotope that occurs the most frequently, or abundance, in nature. So I'm going to use terms like abundance when I talk about these, but when I talk about abundance, I'm talking about how frequent it occurs, so how high the percent is. Meaning, if I had something that was 90% or I had something 10%, my 90% would be considered more abundant compared to my 10% abundance. Okay. So just like an isotope that doesn't occur very often and is worth a lower percentage point, the first 2 quizzes shouldn't count as much because they had fewer points. Now, how do I calculate the average atomic mass? To do this, I'm going to do 3 steps. And these are important. You have this written down if you do not. You're going to convert the percent to decimals, and then you're going to slide 2 spaces to the left. Essentially, you're dividing by 100 when you're doing this, but it's just easier to say slide your decimal 2 to the left. Then you will multiply that mass times the converted decimal or that abundance. The mass that's associated with it, I'll kind of have it very, very clearly out for you so you won't have any confusion about, oh, but I thought I had to do this one or I had to do this one. Trying to make it a little bit easier. Then you would add up the results from number 2. So then once I do my multiply through, I add up all those, and that gives me my average atomic mass. The beauty about this is that if I give you the element, you're able to check yourself on the periodic table because that average atomic mass should equal out to whatever's on the periodic table. Or if I ask you to solve for the element, you just have to go to your periodic table and look for the element. Not too bad. So let's do a practice. We're going to calculate the average atomic mass, and you're going to tell me what element it is. So my isotope mass is 14.003 with a 99.63% abundance. And then I have a 15.000, which is 0.37 abundance. Now, the first step that you need to do is you need to convert our percents to decimals. So it's very simple. We're just going to slide over 2 decimal places. So I would do this in your notebook. Slide it over 2 decimal places, and then you're going to take your 14.003 times your converted, which is 0.9963, and you're going to take 15.000 times my converted, which would be 0.0037, multiply those together, so your 14 and your converted, your 15 your converted, and then you're going to add them together. When you add them together, once you kind of multiply and add, you should get 14.007 AMU. So now you can kind of, like, a good way to assume is go to like what's half of that, and that's what it should be. So if you go to your periodic table and you're like, okay, well, I'm looking for about like 7 protons maybe in that kind of range, then I can look and see, okay, this mass matches with nitrogen. Okay. So now you try this one on your own. It's calculating average atomic mass. I give you the atom, so all you have to do is calculate the mass. So lithium has 2 isotopes. So you're going to do 6.015 with an abundance of 7.5% and 7.016 with an abundance of 92.5%. First step, you're going to convert your decimal. So I'm going to slide it over 2 to the decimal, 2 ways. Just do that with your decimal. Do not do that with your mass. You're going to multiply your mass with your converted decimal, and then you're going to add them together. Take a moment, pause this, and work on that. Here is the answer. you should get about 6.94 AMU. And if you go to the periodic table, you should see that lithium has about 6.94, maybe 1 if it goes to 3 decimals. And that means like, hey, you did it right. Now, it's not a perfect science because they have a lot further decimals than us. So as long as you're in this range, you should be pretty okay. Now, if you're getting an answer like 69 point, then that's where we're going to have a little bit of an issue because that's a calculation error. So that's when you'd want to go back. But if you got, like if you rounded at your decimals, and so you got 6.47 and 0.45, you're going to add those together. You would get like 6.92 instead. So you would get a little bit of a funkier number in that case, but that would be close enough for me. I do recommend not rounding until the very end to get the most accurate answer. That's where a lot of our errors come up, is when we're rounding. Just a reminder for you. However, it is important that you just kind of take the time to practice these. Okay, so we did a simulation lab in class. If you have not done the isotopes or the average atomic mass simulation lab, please take the time to do so. It's just additional practice for you, but you do have to turn it in for a grade. This was the bell ringer for that day. It's okay. All right, so we took a quiz, but let's do one more practice. We're going to calculate the average atomic mass and what is this element. You take the time to go through it, and then I will show you the answer. Okay, so first step, I have to convert my percent. So I'm going to do 7.77 to percent, which would be, or to decimal, which would be 0.7577 and 0.2423. Take those with my mass by multiplying them, add them together, and I would get 35.46. So I get the element of chlorine. All right, now we're going to talk about the periodic table of elements. I do have a couple videos attached here. However, I am just going to kind of go through it a little bit quickly for you because I don't really want to watch a 10-minute video on Zoom or on a Screencastify, so I will summarize it for you. So what does it mean to be periodic? What it means is when something happens on a regular basis or in a cycle, hence why our periodic table has the name of periodic, because we do have a cycle of the elements that we notice, and we'll talk about that. So Mendeleev, he was a Russian chemist in 1869, and he ordered the periodic table according to atomic mass, and he left spaces for new elements that were correctly predicted. He was a very, very interesting guy. So my video I have is a little bit of history behind him and what he's done for chemistry in terms of the periodic table. He was a very intelligent man, but he had a very sad childhood. When he was a child, his father died, and he had 10 siblings, Mendeleev did. And his mom wanted to support them, but back then it wasn't really common for women to work and support their family. And so when the husband died, it's kind of like condemning them that they're going to be in poverty for a very long time unless the sons take up the household or anything with that. History is very wild. So so his mom goes, oh, I need to support my family, and buys a glass factory. Well, that same time, that glass factory burns down, and a bunch of the children pass away because Russia is very brutal. It's rural Russia. It's very cold. And she notices, hey, my son Mendeleev, he is a very intelligent and academically advanced young guy. So she took him on a course, and they went through 400 miles of the Ural Mountains, which are a very, very rough trip to do that in 1869. No telephones, no heat. They went through all those mountains. They had to camp. If you had to stop, you stopped and you were in the woods. You were not going to a gas station by any means. And so they travel 400 miles to, I believe, the capital in Russia, which I can't remember the name of it, but it's just like a very important city. And it had a lot of schools, like universities. And so his mother begs, please take my son. He's academically inclined. He would do wonderful. I want him to be more than what is in rural Russia. And they say, no way, Jose. So they go back home. And then a couple years later, they go, let's try again. So they go, they travel the 400 miles, they camp, they're out in the wilderness, not really having a whole lot of food. food, and they get to the city. She pleads her case, please take my son, he's academically inclined, and they say, sure, why not? And shortly after getting her son there in the city, she passes away because I think, it was like, I'm fulfilled, this is what I wanted to do. So Mendeleev started studying, and he became very interested in chemistry, specifically with the elements. And a lot of scientists around this time are really interested in the elements. We didn't have a way to organize them. We just had, here's what their similar properties are. So, oh, hey, I noticed oxygen. Typically it was more like, I noticed silver and copper and gold. They're all, very similar. They're metal. They have the same malleability. That's kind of all I know. We'll put them in a little group. So they grouped them more on properties. Well, Mendeleev came in and he said, hey, there is a trend that you kind of see. They have similar properties, but they have an increase in our mass number. And so he ordered the periodic table that way. And he was so methodical about this that he could predict that there's an element that would have about this kind of mass and these properties. He was so accurate with his theories in the periodic table and how he organized it that a French scientist, came out and said, hey, I have this element, and it's new, and I'm going to give it a cool name. And Mendeleev said, no, that's not an element, because it did not match where it should have been in the periodic table. And so he was so sought on, this is what it has to be like, that he wrote a paper without even seeing this scientist's element, proving that his element was false. It was not correct. And he was right, which is crazy to think about. Because back then, you're not calling up someone and going, hey, what's up? You have to write papers, you have to write letters, all that crazy stuff. And he was right. Now, for him, which I think is very interesting, he didn't really believe in organized religion, but the periodic table became his religion. He was so bent on making it perfect that he didn't want really anyone to know until he felt it was 100%. And the only reason we got the periodic table that we do have is based on his studies, because it helped other scientists perfect it later down. But he, which this is amazing to me, he only posted his paper with his periodic table because he needed money. I mean, you're a Russian chemist. You're not really making a lot of money. And Russia didn't really have a lot of money, unfortunately. So he needed to post it so he could make some cash to help support himself. And that's the only reason we have it. But he didn't want to post it until he felt it was perfect. It was complete. And it wasn't complete by this time because we couldn't discover a lot of things like gases or some of our liquids there that were technically an element. So it was very interesting. Now, that was the video that I just kind of went over for you. Now, this guy, Henry Moseley, comes out, and he's a very young guy. He's in England. He's 21, and he goes and studies with Rutherford. And if you remember, Rutherford did our gold foil experiment. So he was with a prestigious group of scientists. And this is very interesting to me, a little background. Henry was mainly doing what Rutherford's experiment was to kind of prove his experiment was right. Bell. And he did not like that. And during this time, x-rays came out. So x-rays are really cool to a lot of scientists because they didn't know what this meant for science. How could this improve it? So he was working with this machinery, doing the same project. He did not enjoy it. Well, then one day that it broke down. So he took this opportunity to x-ray different elements to see if there was a pattern or something that he noticed with them. Rutherford said, okay, yeah, if this is what you're interested in, then go ahead. And he made a contraption to go through and get a bunch of samples of x-rays for elements in a very quick way, and he created this contraption to do it. It was very interesting. But he did all this work, he worked day and night. He was so interested in this, so invested in it, that he had all these x-ray samples. And when the x-rays were made, they were just kind of lines on a little sheet of paper. What he did is he took those and he put them on a box, and he saw, hey, there's a staircase pattern with these. So he was able to organize the periodic table into our current model that we know today, where it's by atomic number and not mass number. Now, unfortunately, and this is very sad, he went to World War I and he passed away in war. And he was a very intelligent guy. He's 21. He's probably going to do more than I'm ever going to do in science with my life, which is crazy. He's wonderfully smart. But when he passed away, a lot of scientists were very upset because they felt, here's this smart young man, and he went and fought for his country, which is, wonderful. But he was taken too young, because who would have known what Moseley could have came up with if he did not pass away at such a young age. But we have the periodic table from him. We have to thank him for that. It's wonderful. So there's a periodic table. Thank you, Henry Moseley. So, periodic table. Moseley found out the periods are along our horizontal rows. Okay, so those are my periods. Where I get my periodic kind of idea. So I get my increasing atomic number. Now, groups are along the vertical columns, and the groups are what we call families as well. Now, we have three things that we deal with on the periodic table. We do have specific families that have fancier names, but just know it's composed of these three things, primarily metals, metalloids, and nonmetals. And here's our fancy special groups. These are what you're going to label on your periodic table in the lab. If you have not done that already, please take this as a moment to do so. Now, lanthanides and actinides, those are what we have on this bottom right there. And if we put them into our periodic table, it would look a little bit like this. It wouldn't fit on a piece of paper, so that's why we kicked them out, because it was a lot more difficult to print out a piece of paper like this. So that's why they're on the bottom, but they should fit in just like this, which is really crazy. All right, so my period is horizontal, my family and group are vertical, and my stair step is my equator. When I say stair step, I'm talking about this right here. Now we have the metals, nonmetals, and metalloids. The metals are the left of your stairs, and they are the majority of the elements. It's about 80% metals on our periodic table. Properties of metals are they're good conductors, they have a luster or a shininess, they're ductile, they can be made in wires, they're malleable, meaning they're bendable, they're solids at room temp, all except mercury. Mercury is the only one for the metals that is liquid at room temp. Nonmetals are the right of the stairs. Those are poor conductors. They're mainly gases at room temp. Some are solids, some are liquids, but they're primarily gases. And then they're brittle. And the metalloids are on the stairs, and they're a mixture of properties between metals and nonmetals. Those ones are highlighted specifically. So aluminum is technically a metal, whereas silicon would be considered a metalloid, for you to know. All right, so now groups on the periodic table. So elements that are in the same group, so my little vertical, have similar, they share similarities. So meaning they can have, like copper, silver, gold, they can have the same color or appearance. So their malleability, their luster, they might not be all the same color, but they have about the same luster or shininess. So gold, silver, and copper, if you looked at them when they're not old, they would have about the same shine. They have the same state of matter. So with my copper, silver, gold, they're all solid at room temperature. And then they have similar reactivity with other chemicals, which is important to know. So there's, again, my metals, metalloids, and nonmetals. And then a part of your test will be to know the first 86 elements of the periodic table. I do have a song for you that I showed you in class. However, please use it. I used it to study. It was wonderful, and it's the periodic table song. I recommend it. All right. So we did a couple activities. So if you have not done these, I do suggest that you color in your periodic table. Use the website ptable.com. That will help you a lot. I recommend using it on a computer. The part 2 is complete the P-table scavenger hunt. It's a worksheet. And then study for the speed periodic table quiz. It's over the first 86 elements, and I did post a Quizlet to Canvas for you. That's all I have for you today, though, so I hope that helps, and I hope you have a wonderful day. I will see you next week. Bye.